In this video, I will tackle the trickiest P1 questions that had the potential to fry your brain if they showed up in your papers. But luckily they didn't. So sit back and watch till the end on how to tackle these stupid Edexcel questions. What the heck is this? Interesting. So this is May 22, my year, the year I gave exam in. But I don't think I solved it in my exam. But let's see. Figure 4 shows part of the graph of the equation y equal to sine x, given that sine alpha is equal to p, where alpha is between 0 and 90. So this is a normal sine x graph. So 90 is gonna be here, 180, 270, 360. And this is minus 90, minus 180, minus 270, and minus 360, and they are symmetrical. Given that sine alpha is p, sine alpha is p, where alpha is between 0 and 90. Okay, so alpha is a value for x, and when sine is sine x value, when x value takes alpha, y value is p. That is what they mean. So when x value is alpha, it is somewhere between 0 and 90. Y value at that point will be p. Okay, this is what they mean from the first line. State in terms of p the value of 2 sine 180 minus alpha. 180 minus alpha. That means from 180 I went alpha distance backwards. So 180 minus alpha. So now if I go alpha distance backwards, I'm still gonna get the same y coordinate. The same y coordinate, which is p. Why? Because according to symmetry, sine graph is symmetrical about its turning points. So this is a turning point. It is symmetrical about this point. Sine graphs are symmetrical to the right side and to the left side. They are symmetrical. So if I consider that from 0 point, if I went alpha, it is p. Again from 0 point I went alpha distance to the left, it is also p. So at this point it will also be p. But they want 2 times sine 180 minus alpha, so it will be 2 times of p. So 2p is the answer. For the next question, sine alpha minus 180. Now for trigonometric questions, we have to bring the number at first just to see how much distance I traveled. Especially for P1, they are asking symmetry questions these days. So you have to bring the number at first. Let's rearrange it and write it as sine minus 180 plus alpha. Just for our simplicity, if someone can do with alpha minus 180, that's not a problem. So alpha minus 180, that means from minus 180 I went alpha boxes forward because it's plus alpha. So minus 180 I went plus alpha, so it is somewhere here. Now logic states that compared to the y-axis, they are symmetrical towards one another in the opposite way. For example, at 90 the value is minus 1, and at 90 the value is 1 for y, and at minus 90 the value is minus 1. What? So for minus 180 it is 0, 180 it is 0. To the right side it will be positive, to the left side it is negative. For the second question, they are asking for sine alpha minus 180. So what I will do is I will rearrange it at first, because all trigonometric questions I'll try to use as much of symmetry as possible. So this means sine minus 180 plus alpha. Sine minus 180 plus alpha. So if I do minus 180 and if I add alpha to it, from minus 180, so minus 180 is this point, if I add alpha distance to it, if I observe from the y-axis, they are mirrored of one another, mirrored images of one another. So that means from minus 180, if I go alpha distance, I should get minus p. Because from 180 I went alpha distance backward, I got p. So from minus 180 I went alpha distance forward, I should get minus p according to symmetry. So this one's answer is simple, only minus p. Next one, 3 sine 180 plus alpha. So from 180 I added alpha. So this is my 180 point. and I added alpha distance to it, and I am seeing that I know that considering one point, if I look at the right and the left, sine curve will maintain a symmetry, they will be mirrored. So if this is p, that will be minus p. So sine alpha plus 180 will give me minus p, but they want 3 sine 180 minus 180 plus alpha, so it is 3 plus p, sorry, 3 minus p. Okay. A copy of figure 4 labeled diagram 1 is shown on page 27. Draw a graph of y equal to sine 2x. So this is sine x, normal graph, 90, 180, 270, 360. For y equal to sine 2x, whatever we are observing now, the exact same thing will happen, but the interval will be divided by 2. The x-axis coordinates will be divided by 2. What does it mean? For example, it is reaching maximum at 90. Y equal to sine 2x will reach a maximum of 9 at 90 divided by 2, so it will reach a maximum at 45. It is reaching a cutting point at 180. It is cutting x coordinate x-axis at 180, so it will not cut at 180 now, it will cut its first x-axis at 90. So this is the graph, and then I can repeat the pattern, 180 and then 270 and then 360. If you get two curves within this interval, that means your drawing is correct. You will do the same thing, minus 90, minus 180, minus 270, minus 360. You will do the same thing on the left side. Oh, another thing, it cannot go above or below 1 and minus 1. It has to stay within 1 and minus 1 because there is no transformation with the y coordinates. Okay, good enough. Hence find in terms of alpha the x coordinates of any points of intersection where sine 2x is equal to p. Okay, sine 2x is equal to p. Sine 2x equal to p. No, I have to connect it because alpha does not exist in sine 2x. It will be very difficult, but I know that sine alpha is p. So if I connect it, sine 2x equal to sine alpha, yes, it matches. So 2x will be alpha, x will be alpha by 2, and by cast rule another angle will be 180 minus alpha by 2. So this is the answer. Okay, so this is October 19, question number 9. Once again another trigonometric question, and we will solve it the same way we used to solve our first question. Figure 5 shows the curve with the equation of the curve C with the equation what? So where was I? Figure 5 shows a sketch of part of the curve with the equation y equal to sine x by 12, where x is measured in radians. The point M shown is the minimum point on C. State the period of C. Okay, normally a sine curve has a period of 2 pi. That means after every 2 pi there is one cycle completed, or after every 2 pi the same value is repeated. But in here it is not sine x. For sine x it is 2 pi, the period is 2 pi, but it is sine x by 12. There is a transformation and it is divided by 12. X is divided by 12, and we know whatever happens with x, the opposite thing happens. So in this case it is divided by 12, so the coordinates will be multiplied with 12. All the x coordinates will be multiplied with 12. So in this case it was 2 pi, so it will be 2 times 12 pi, so 24 pi. Another way someone can do is, normally in here it is pi by 2, in here it is pi by 2, in here it is pi, and in here it is 3 pi by 2, and in here it is 2 pi. But in here, in this case, normally this would happen for y equal to sine x, but it is sine x by 12, so everything will be multiplied with 12. So everything will be multiplied with 12. So if I see 2 1s are 2, 2 6 are 12, 6 3s are 18 pi here. So this is 18 pi, and this is 6 pi. This point is 6 pi. 6 pi, 12 pi, 18 pi, and 12 times 2 pi, which means it is 24 pi in this point. 24 pi in this point. So let me just erase it here. 6 pi, 12 pi, 18 pi, 24 pi. Okay, so the period is 24 pi. State the coordinates of m. We already deduced it. It is 18 pi, and I know there is no transformation with the y. If there was transformation with the y, there would be a multiplication or addition outside the bracket. But in here there is no transformation, so it is still between 1 and -1. So my minimum point will be at -1. So 18 pi and -1. Okay, the smallest positive solution of the equation sin x by 12 equal to k, where k is a constant, is alpha. Find in terms of alpha the negative solution of the equation that is closest to 0. That means they want the smallest negative solution for sin x by 12 equal to k, and the solution is alpha, meaning the meaning of this line is when x is alpha, y is k, as simple as that. So now if I draw this graph, it would look something like this, and they want the negative solution when it is equal to k, when the graph is equal to k. So when the graph is equal to k, it means the line k is cutting at multiple points. So the first negative solution will be somewhere here, and I know that sine graph is symmetrical. So if this is 6 pi, this will be -6 pi, and this will be -12 pi, and this maximum point will be -18 pi. And I know that I went from -12 pi, I went alpha distance this way. Why? Because I went alpha distance from my 0 point here, I went alpha distance from my 0 point here as well. So it will be from -6 pi, so it will be -12 pi, it is this point, minus alpha, because I have to go alpha step backward to reach k. So it is -12 pi minus alpha. Okay, the smallest positive solution of the equation cos x by 12 equal to k. So if I drew a cos graph here, cos graph would start from here as well. Cos graph would start from here, and it would continue, and at 90 it would, at 90 maybe a bit proper drawing, at 90 it would cut, meaning at 6 pi it would cut, and it is cutting point k when it is minus alpha distance backward. So it is 6 pi minus alpha, it is cutting k. That is one way we can do. If you want to do algebraic way, I know that if I want to get the same value for cos, I know that sine 90 minus alpha is cos alpha, but in this case 90 does not exist. So if I want the same solution, let's say sine 180, sine let's say sine 45, it will be same as cos 90 minus 45. They are the same values. Exactly same way what I can do here is, instead of writing sine here, I can convert it to cos to get the equation. So sine alpha, I know it gives k. Sine when x is alpha, it is k. So I want to convert it to cos. So cos 90 minus alpha, no, it will not be 90 here, it will be 6 pi because of the transformation. It will also be equal to k. So my solution is 6 pi minus alpha. Okay, more of sine and cos waves. Figure 4 shows part of the curve with the equation a cos x minus 30. This is January 2022 P1. Okay, the point P is a minimum point on the curve and has coordinates 30 and -3 as shown. Okay, 30 and -3 as shown on figure 4. Write down the value of A. Okay, before doing any transformation, let's look at the base graph of cos x. Normally a cos graph would start from 1 and reach a minimum of -1, and it would have its first iteration at 360 degree. Okay. In this case, since it is x minus 30, it would move 30 boxes forward. So this point right here, it would be here now. This point right here, it would be somewhere 30 boxes shifted. It was 90 degree, it will be 120 degree now. This point, it was 360, now it will be 390 now. It shifted to the right. It shifted to the right. So this point right here, so it shifted a little 30 boxes to the right. But the problem here is, look, this graph and this graph, they are not matching. You are seeing a complete opposite graph. It got flipped. So if a graph gets flipped, it means that it is multiplied with a negative number. It is multiplied with a negative number. So what happened here? See, it went a minimum of -3. That means surely it went a maximum of +3. That means if it is flipped, the coordinates are flipped. Normally if you multiplied, let's say 2 cos x, then this point would be 2, this point would be -2, because they are multiplied. Exactly same way, when I multiply with a negative number, what happens is, let's say this is 1 and -1. If I multiply with a negative number, this part would be positive. If I multiply this with a negative number, this part would be negative, meaning they got flipped. So in this case, since it is -3 and +3, that means it got multiplied with -3, because two criterias. One is the maximum point change from 1 to 3, and another point is the graph got flipped. So surely it has to be a negative number multiplied. Okay, so the value of a is -3. Figure Q shows it is a maximum point, right? Find the coordinates of Q. Okay, so if this is 30, that means every single point, normally whatever you would expect, it is 30 boxes more. So normally you would expect this point, see the relationship, this and this, they are exactly same, just it will be 30 boxes forward. So it was 90, it will be 90 plus 30 now. This was 360, first iteration it was 360. So 90, 180, this point it will be 360 plus 30 now. In this way we have to find the coordinate, and if I carry on, I will see that for example this point it will be 180 plus 30, and I know that sine cos graph iterates after 360 degree, period is 360. So it will be 360 plus 180 plus 30. This will be 360 plus 360 plus 180 plus 30, meaning every time 360 gets added from one maximum point to the next maximum point, 360 gets added. See, it was 0 here and it became 360 here. That means from one maximum to another maximum, 360 degrees added every time. So from here to here, 1 360 will be added. From here to here, 1 360 will be added. So I think overall answer is 930 degree for Q. And I know that this point is 3. So 930 and 3 is my final answer. By the way, 360 degree is added from minimum to minimum as well, so don't be confused. Anyway, this is the end of the first video for this series solving the trickiest P1 questions, and hopefully I'll come with the next video very soon.